Hello students, today we'll discuss another problem related to Thevenin's theorem. The question given, the find current through the 10 ohm resistor using Thevenin's theorem. Here there is a load resistor RL. Now we are going to calculate how much current flow to the 10 ohm resistor by using Thevenin's theorem. Let this is your IL. I can say this is your load resistance RL. We are going to calculate the current flow to the 10 ohm resistor using Thevenin's theorem. So what we will do, generally in Thevenin's theorem, in step 1, what we will do first? We have to disconnect the load resistance and find out the Thevenin's voltage and Thevenin's resistance. If we will disconnect this one, first of all, we have to disconnect the load resistance. We can calculate here, that is your VOC or VTH. In Thevenin's voltage, how to calculate Thevenin's voltage? In step 1, first of all, you disconnect the load resistance and find out the open circuit voltage or Thevenin's voltage. If you observe this network here, simply there is a branch, this is your open circuited, and the current, is there any current flow through this branch? No, because simply this is a open circuited here. This is open circuited. There is no current flow through this branch. Only the current flow through this branch. So we can calculate this voltage. This voltage, how to calculate this voltage? So no current flow through this branch. Because this is open circuited, we are going to calculate VOC or VTH. So first of all, we calculate how much voltage across this 2 ohm resistor here. So then naturally, how much current flow through this 2 ohm resistor? The current is how much here? I equal to, the value is how much? That is your 20 by 20 divided by 5 plus 2, that is your 7 ampere. That is your I. Here that is your, we are going to calculate Thevenin's voltage. Thevenin's voltage. Thevenin's voltage. So I value is like this. Current, simply this network or this circuit, this closed loop, we can find out the current. That is your 20 divided by 5 plus 2. That is your 20 by 7 ampere. And this voltage is how much? That is your current into this resistor. So I can write this is nothing but C, and this point is your D. So potential across 2 ohm resistor, we can say that is your VCD. Potential across 2 ohm resistor is nothing but, I am naming this one, that is your VCD. That is your voltage across 2 ohm resistor. That is your I into 2 ohm. The current is your 20 by 7 into 2. Or you may apply the voltage division rule. That is your, this resistor are series. This voltage is nothing but 20 into 2 divided by 5 plus 2. So that is your 5 plus 2, that is your 7. The value which comes around 40 by 7 volt. This is your VCD. Then we are going to calculate here VTH. Remember here, since it is open, there is no current flow through this branch. So I can say VTH. So this is your VCD. This voltage is nothing but VCD, and this is nothing but 8, and this is your 12, and this voltage I can say that is your VTH. So VTH value, how we will calculate VTH? Previously, when I have disconnected that resistor, there is no current flow through this branch. There is no current voltage drop across 8 ohm resistor, because there is no current flow through this 8 ohm resistor. So only we will consider the 12 volt source. So VTH value is how much? If you apply KVL here, that is your VCD, here that is your 12 minus VTH equal to 0. If you apply KVL, apply Kirchhoff's voltage law, that is your VCD, that means the potential plus CD, VCD equal to 40 by 7 volt. So VCD, there is no current flow through the 8 ohm resistor. You have to consider this voltage source, that is your 12 volt. VCD minus 12 plus to minus VTH equal to 0. Or VTH value is how much? VTH equal to VCD, potential across the terminal CD, VCD minus 12. This is your VTH. So this type of question may ask in your competitive examinations. If you should not confuse this branch, because there is no current flow to this branch. So only you have to consider this voltage source. So VTH equal to VCD minus 12. So VTH, Thevenin's voltage, equal to your VCD minus 12 volt. VCD is your how much? 40 by 7 volt. 40 by 7 divided by 40 by 7 minus 12. If you are using calculator, that is your 40 by 7. It is around 5.71. That is your 5.71 ohm minus, sorry, volt minus 12. Minus 12. The value is your what? Minus 6.2 volt. Minus 12. It is around minus 6.28 volt. This is your VTH. Okay. So VTH equal to here, that is your minus 6.28 volt. So VTH equal to minus 6.28 volt. That is your Thevenin's voltage. Okay. Then come to RTH. In step 2, calculate RTH. To calculate RTH. How to calculate RTH? Already I told you. To find Thevenin's resistance, all the voltage source should be short circuited and current source should be open circuited. So there is no current source in this networks. So only two voltage source, 20 volt, here 12 volt. If we'll draw the circuit using Thevenin's equivalent circuit, Thevenin's, how to calculate the Thevenin's resistance, all the voltage source should be short circuited. Here 20 volt, it's short circuited here, and this is your 5 ohm, and this is your 2 ohm. Here there is your 8, and this will be short circuited here. We will calculate RTH. To find RTH, this is your A and this is your B. To calculate RTH, the voltage source should be short circuited here. There is a voltage source here. It is short circuited. Here voltage source, there is short circuited, and we have to calculate the Thevenin's resistance, that is your RTH. How to calculate RTH? This is a 5 ohm and this is a 2 ohm. This 5 ohm and 2 ohm is parallel and 8 ohm is series. So equivalent resistance is how much? If you look from this from AB, the RTH value is your 5 ohm. The RTH is your 5 ohm parallel what? That is your 2 ohm plus series with, that is your 8 ohm. This is nothing but your RTH. The value of RTH is how much? The RTH equal to, if the two resistance are parallel, then the equivalent resistance is your product of the resistance by sum of the resistance. So 5 parallel 2, that is your 5 into 2, that is your 10. 5 plus 2, that is your 7 plus 8. The value is how much? 10 by 7 plus 8 by using calculator. So 10 by 7, that is your 1.42, 1.428 plus 8. The value is around how much? 9.428 ohm. That is your RTH. Then finally, what we'll do? Finally, we will draw the Thevenin's equivalent circuit. So here I have disconnect the resistance. The resistance, that is your what? That is your, to find 10 ohm resistor. So if we will rerun the circuit, if we will Thevenin's equivalent circuit, we have to rerun the Thevenin's equivalent circuit. So Thevenin's, finally in step 3, Thevenin's equivalent circuit, in step 3, after getting Thevenin's voltage and Thevenin's resistance, finally we will draw the Thevenin's equivalent circuit, that is your VTH and RTH. Here VTH comes negative, that's why this is your plus terminal and this is your minus terminal. Plus to minus is minus, and this is your VTH. The value is what? 6.28. We don't write minus because I have alternated the source terminal plus and minus. That's why I can write 6.28 volt. Then series with resistance, Thevenin's resistance, it is around what? 9.428 ohm. That is your Thevenin's resistance. Then here, that is your AB, that is your 10 ohm resistor. Finally, you connect the Thevenin's resistance, that is your RL. The value of RL is your 10 ohm. Clearly, the two resistors are in series, and you can find out the current. The current value is nothing but Thevenin's, that is your load current IL, because this is your A and this is your B. The current flow from what? B to A, because this is a minus terminal and this is a plus terminal. The current flow through the direction is from what? B to A. So how much current flow through the 10 ohm resistor? The question asks to find out the current flow to the 10 ohm resistor using Thevenin's theorem. So IL, the value of IL is how much? The IL is your Thevenin's IL equal to Thevenin's voltage, that is your 6.28 volt, divided by the sum of the resistor, that is your 9.42 plus, that is your 10. The value is around what? 6.28 divided by 19.428. The value is around how much? By using calculator, that is your 6.28 divided by your 19.428. The value is around 0.323. That is your 0.323 ampere, and the direction is must. The direction is what? The current flow through the B to A. In right side you can write B to A. The current flow to the 10 ohm resistor, the direction is what? B to A, because this is a minus terminal and this is your plus terminal, and current flow through the from B to A. Okay, here Thevenin's voltage is your 6.28 volt. In step 1, we have calculated the Thevenin's voltage. How we will calculate Thevenin's voltage? Disconnect the load resistance. Means what? The resistance, we are going to calculate how much current flow through that resistance. First you disconnect the load resistance, then find out the open circuit voltage or Thevenin's voltage. How to find out the VTH or VOC? Since it is open circuited, there is no current flow to this branch, because this is open circuited. There is no, the loop is not closed. So that's why the current is not flow through this branch. Only we have to calculate here voltage across this 2 ohm resistor. How to find out the voltage across this 2 ohm resistor? By using voltage division rule, or you may calculate the current equal to 20 by 5 plus 2, that is your 7 ohm, 20 by 7, current into this resistance, or we may say the potential across the C terminal and D terminal, potential across CD equal to how much? 20 into 2 by 5 plus 2, that is your potential across CD. Then there is a little bit of understanding how to calculate VTH. You know this voltage, that means what? Previously when it was disconnected, there is no current flow through this branch. Only you have to consider this voltage source. So VCD minus 12 minus VTH equal to 0, then you can calculate VTH. So VTH comes negative, that is your minus 6.28 volt. This is all about step 1. In step 2, what we are doing? In step 2, we have to calculate the Thevenin's resistance. How to find Thevenin's resistance? In Thevenin's resistance, first of all the voltage source should be short circuited and current source should be open circuited. So there are two voltage source. The two voltage source here it is short circuited, here it is also short circuited. You have to find out, if you look from this side, what is the equivalent resistance or Thevenin's resistance. Simply, clearly this 5 ohm 2 ohm are parallel. Equivalent resistance is how much? 5 into 2 by 5 plus 2. If the two resistances are parallel, the equivalent resistance is product of the resistance by sum of the resistance. So equivalent total resistance or RTH equal to 5 parallel to series with 8. 5 into 2 by 5 plus 2, that is your 10 by 7 plus 8, and the resistance RTH equals, it comes around 9.428 ohm. So we have calculated VTH, we have calculated RTH. Finally, in step 3, we redrawn the Thevenin's equivalent circuit. This is your Thevenin's voltage. If it is plus, then it will be plus and it will be minus. Since VTH equal to minus 6.28 volt, this terminal is minus and this terminal is plus, because VTH equal to minus of 6.28 volt. Then connected the RTH. Here RTH equal to 9.428 ohm. Simply you connected the RTH. Finally, the disconnected load resistance, finally you connect this one. That is your 10 ohm. The question asks, find the current flow to the 10 ohm resistor using Thevenin's theorem. So you connect the load resistance 10 ohm, then calculated how much current flow to the 10 ohm resistor. Simply circuit, there is one voltage source and there is two resistance, current equal to voltage by sum of the resistance. So VTH by 6.28 divided by 9.428 plus 10, the current comes, it is around 0.323. And here you have to mention the direction of current, that is your B2A. So okay, so next class, more and more number of problems we'll discuss about how you will solve using Thevenin's theorem. Thank you.